Welcome. Today we're diving into the fascinating world of colloids. Colloids are mixtures where tiny particles are dispersed throughout another substance, but these particles are not dissolved. They're larger than molecules found in solutions, yet small enough to remain suspended without settling quickly. Colloids are all around us, from milk and fog to paints and gels. In this video, we'll explore the different types of colloids, their unique properties, and intriguing phenomena like the Tyndall effect and Brownian movement. We'll also discuss how colloids can be coagulated or separated. Let's begin our journey by understanding what makes colloids so special and why they're important in both nature and industry. Colloid is a heterogeneous mixture where one substance is dispersed evenly throughout another. The dispersed particles are typically between 1 and 1,000 nanometers in size. Unlike solutions, where solute particles are molecular in size and invisible, colloidal particles can scatter light and are visible under a microscope. These mixtures don't separate on standing and can't be filtered easily. Everyday examples include mayonnaise, smoke, and whipped cream. Understanding colloids helps us appreciate many products and natural phenomena. Now let's look at the main types of colloids based on the states of their dispersed phase and dispersion medium. Colloids can be classified based on the physical states of their dispersed phase and dispersion medium. There are 8 main types: sol, gel, emulsion, foam, aerosol, solid sol, solid foam, and solid emulsion. Each type has unique characteristics and examples. For instance, sols are solid particles in a liquid like paint, while emulsions are liquid droplets in another liquid such as milk. Understanding these types helps us recognize colloids in daily life and in industrial application. Next, we'll explore each type in more detail, starting with sols. Sol is a colloidal system where solid particles are dispersed in a liquid medium. Common examples include paints, inks, and blood. The solid particles remain suspended due to their small size and constant movement. Sols are often used in industrial processes, such as the manufacture of ceramics and pharmaceuticals. Their stability and ability to carry other substances make them valuable in many fields. Next, let's look at gels, which are closely related to sols but have a different structure. Gels are colloidal systems where a liquid is dispersed within a solid network. Think of jelly, cheese, or gelatin desserts. The solid framework traps the liquid, giving gels their unique texture. Gels are important in food, cosmetics, and medicine. Their ability to hold water and maintain shape makes them useful for wound dressings and drug delivery. The transition between sol and gel forms is reversible in some cases, allowing for versatile applications. Now let's move on to emulsion. Emulsions are colloids where tiny droplets of one liquid are dispersed in another liquid. Milk and mayonnaise are classic examples. Emulsions are often unstable and require emulsifying agents to prevent separation. These agents, like lecithin and egg yolk, help keep the droplets suspended. Emulsions are essential in food, cosmetics, and pharmaceuticals, providing texture and stability. The science behind emulsions is key to creating products like salad dressings and lotion. Next, let's explore foams. Foams are colloidal systems where gas bubbles are dispersed in a liquid. Shaving cream, whipped cream, and frothy beverages are all foams. The bubbles are stabilized by surfactants, which reduce surface tension and prevent the gas from escaping quickly. Foams are used in food, firefighting, and cleaning products. Their light, airy texture is both functional and appealing. Let's now look at aerosols, another common type of colloid. Aerosols are colloids where either solid or liquid particles are dispersed in a gas. Examples include fog, mist, and smoke. In fog, tiny water droplets are suspended in air, while smoke contains solid particles. Aerosols play a significant role in weather, air quality, and even disease transmission. They're also used in products like spray deodorants and air fresheners. Understanding aerosols helps us manage pollution and develop better delivery systems for medicine. Now let's discuss solid sols. Solid sols are colloidal systems where solid particles are dispersed in another solid. Alloys, colored glass, and some gemstones are examples. The dispersed particles are so small that they don't settle or separate, giving the material unique properties like color or strength. Solid sols are important in materials science and engineering, allowing us to create new materials with tailored characteristics. Next, let's look at solid foam. Solid foams are colloidal systems where gas bubbles are trapped in a solid matrix. Examples include pumice stone, styrofoam, and some sponges. The trapped gas gives these materials their lightweight and insulating properties. Solid foams are widely used in construction, packaging, and insulation. Their structure makes them both strong and light, ideal for many applications. Now let's move on to solid emulsion. Solid emulsions are colloidal systems where liquid droplets are dispersed in a solid. Butter and cheese are common examples. The liquid phase is trapped within the solid, giving these foods their texture and taste. Solid emulsions are important in food science, helping to create products with specific mouthfeel and stability. Understanding solid emulsions allows food technologists to innovate and improve products. Now, let's summarize the types of colloids before moving to their property. Recap: colloids can be classified into sols, gels, emulsions, foams, aerosols, solid sols, solid foams, and solid emulsions. Each type is defined by the physical state of its dispersed phase and dispersion medium. Recognizing these types helps us understand the diversity and importance of colloids in everyday life and industry. With this foundation, let's now explore the unique properties that set colloids apart from other mixtures. Colloids exhibit several unique properties that distinguish them from true solutions and suspensions. These include the Tyndall effect, Brownian movement, electrophoresis, and coagulation. These properties arise due to the size and behavior of colloidal particles. Understanding these properties is crucial for applications in medicine, industry, and environmental science. Let's start by exploring the Tyndall effect, a phenomenon that makes colloids visually distinctive. Tyndall effect is the scattering of light by colloidal particles. When a beam of light passes through a colloid, the particles scatter the light, making the path visible. This is why we can see sunlight streaming through mist or dust in the air. The Tyndall effect helps distinguish colloids from true solutions which do not scatter light. This property is used in laboratories to identify colloidal systems. Next, let's look at Brownian movement, another fascinating property. Brownian movement refers to the random, zigzag motion of colloidal particles in a dispersion medium. This motion is caused by collisions with molecules of the dispersion medium. Brownian movement helps keep colloidal particles suspended and prevents them from settling. This property is crucial for the stability of colloids and is observed under a microscope. The phenomenon was first described by botanist Robert Brown in 1827. Now let's discuss the electrical properties of colloids. Electrophoresis is the movement of colloidal particles under the influence of an electric field. Colloidal particles often carry an electric charge, causing them to migrate towards the oppositely charged electrode. This property is used in laboratories to separate and analyze colloidal particles such as proteins and DNA. Electrophoresis is essential in biochemistry and forensic science. Next, let's explore the concept of coagulation in colloid. Coagulation is the process by which colloidal particles aggregate and separate from the dispersion medium. This can occur naturally or be induced by adding electrolytes, changing temperature, or applying mechanical force. Coagulation is important in water treatment, where impurities are removed by causing colloidal particles to clump together and settle. Understanding coagulation helps us control and utilize colloids in various industries. Now, let's discuss the stability of colloid. Colloids are generally stable due to the small size of their particles and the presence of charges that prevent aggregation. Stability can be affected by temperature, pH, and the presence of other substances. Surfactants and stabilizers are often added to maintain colloidal stability in products like creams and paints. Loss of stability leads to coagulation or precipitation. Maintaining colloidal stability is crucial in food, pharmaceuticals, and cosmetics. Next, let's look at the role of charge in colloidal systems. Colloidal particles usually carry an electric charge, either positive or negative. This charge creates a repulsive force between particles, preventing them from coming together and settling. The charge is acquired through adsorption of ions from the dispersion medium. The presence of charge is essential for the stability and behavior of colloids. Manipulating the charge allows us to control coagulation and separation processes. Now, let's discuss the electrical double layer. Electrical double layer is a structure that forms around colloidal particles due to their charge. It consists of a layer of ions adsorbed onto the particle surface and a diffuse layer of oppositely charged ions in the surrounding medium. This double layer creates a potential difference known as the zeta potential, which influences the stability of colloids. A high zeta potential means strong repulsion and greater stability. Next, let's look at the process of peptization. Peptization is the process of converting a precipitate into a colloidal solution by adding a suitable electrolyte. The electrolyte causes the particles to acquire a charge, which disperses them throughout the medium. Peptization is used in laboratories to prepare colloidal solutions from freshly formed precipitates. This process is important in the manufacture of colloidal products and in analytical chemistry. Now, let's discuss the purification of colloid. Colloidal solutions often contain impurities like ions and small molecules. Purification is necessary to remove these impurities and obtain pure colloids. Common methods include dialysis, ultrafiltration, and electrodialysis. Dialysis uses a semipermeable membrane to separate small impurities from colloidal particles. Purification is crucial for research and industrial applications, ensuring the quality and performance of colloidal products. Next, let's look at the optical properties of colloids. Colloids exhibit unique optical properties due to the interaction of light with their particles. The Tyndall effect is the most well-known, but colloids can also show colors that depend on particle size and composition. For example, gold soles appear red or purple. These optical properties are used in sensors, displays, and art. Understanding how colloids interact with light helps us develop new technologies and materials. Now, let's discuss mechanical properties. Colloidal systems can exhibit interesting mechanical properties, such as viscosity and elasticity. The presence of dispersed particles affects how colloids flow and respond to stress. For example, gels are elastic while sols are more fluid. These properties are important in food, cosmetics, and materials science. By controlling the composition and structure of colloids, we can design products with specific textures and behaviors. Next, let's look at the kinetic properties of colloid. Kinetic properties of colloids refer to the movement and behavior of particles within the dispersion medium. Brownian movement is a key kinetic property, ensuring that particles remain suspended. Diffusion and sedimentation rates are also influenced by particle size and medium viscosity. These properties determine the stability and shelf life of colloidal products. Understanding kinetics helps in designing stable colloidal systems for various applications. Now let's discuss the role of surfactants in colloids. Surfactants are substances that lower the surface tension between two phases, such as oil and water. In colloids, surfactants help stabilize emulsions and foams by preventing the dispersed particles from coalescing. Common surfactants include soaps and detergents. They are essential in products like shampoos, creams, and cleaning agents. By choosing the right surfactant, manufacturers can control the stability and properties of colloidal systems. Next, let's look at the industrial applications of colloids. Colloids play a vital role in the food industry. Many foods, such as milk, butter, ice cream, and sauces, are colloidal systems. The texture, appearance, and stability of these foods depend on the properties of their colloidal components. Food technologists use emulsifiers and stabilizers to create products with desirable qualities. Understanding colloids allows for innovation in food processing and preservation. Now, let's explore colloids in medicine. Medicine colloids are used in drug delivery systems, intravenous fluids, and diagnostic agents. Colloidal drug carriers improve the solubility and bioavailability of medications. Blood plasma is a natural colloid, essential for transporting nutrients and waste in the body. Medical colloids are designed for safety, stability, and effectiveness. Their unique properties make them invaluable in modern healthcare. Next, let's look at colloids in environmental science. Colloids are important in environmental science, especially in water purification and pollution control. Many pollutants exist as colloidal particles in water and air. Techniques like coagulation and flocculation are used to remove these particles from drinking water and wastewater. Understanding colloids helps us develop better methods for cleaning the environment and protecting public health. Now, let's discuss colloids in industry. Colloids are used in a wide range of industries, including paints, cosmetics, pharmaceuticals, and mining. Their unique properties such as stability and ability to carry other substances make them valuable in manufacturing and processing. Industrial colloids are engineered for specific purposes, from improving product texture to enhancing chemical reactions. The study of colloids continues to drive innovation and efficiency in industry. Next, let's look at some interesting natural colloids. Nature is full of colloidal systems. Milk, blood, latex, and even clouds are examples of natural colloids. These systems play essential roles in biological processes in the environment. For instance, blood transports oxygen and nutrients while clouds regulate weather patterns. Studying natural colloids helps us understand life and develop biomimetic materials. Now, let's discuss the preparation of colloids. Colloids can be prepared by two main methods: dispersion and condensation. Dispersion involves breaking down larger particles into colloidal size using mechanical or chemical means. Condensation involves building up particles from smaller units, often by chemical reactions. The choice of method depends on the desired properties and application. Proper preparation ensures stability and effectiveness of colloidal products. Next, let's look at the purification process in more detail. Dialysis is a common method for purifying colloidal solutions. It uses a semi-permeable membrane to separate small impurities from colloidal particles. The membrane allows ions and small molecules to pass through while retaining the larger colloidal particles. Dialysis is widely used in laboratories and industry to obtain pure colloidal systems. This process is essential for research and product development. Now, let's discuss ultrafiltration. Ultrafiltration is an advanced purification technique that uses special membranes to separate colloidal particles from smaller impurities. It is more efficient than dialysis and can handle larger volumes. Ultrafiltration is used in water treatment, food processing, and pharmaceuticals. This method ensures high purity and quality of colloidal products. Understanding purification techniques is vital for producing safe and effective colloidal systems. Next, let's look at the role of temperature in colloidal stability. Temperature can significantly affect the stability of colloidal systems. Higher temperatures may increase particle movement, leading to aggregation or coagulation. Some colloids are stable only within a specific temperature range. Controlling temperature is crucial in manufacturing and storing colloidal products. Understanding the effect of temperature helps prevent unwanted changes and ensures product quality. Now, let's discuss the effect of pH on colloid. pH of the dispersion medium can influence the charge and stability of colloidal particles. Changes in pH can alter the surface charge, leading to coagulation or precipitation. Many colloidal products are formulated to remain stable within a specific pH range. Monitoring and adjusting pH is essential in food, pharmaceuticals, and cosmetics. Understanding pH effects helps maintain the desired properties of colloidal systems. Next, let's look at the role of electrolyte. Electrolytes are substances that dissociate into ions in water. Adding electrolytes to colloidal solution can neutralize the charge on colloidal particles, leading to coagulation. This property is used in water treatment to remove impurities. The type and concentration of electrolyte determine the effectiveness of coagulation. Understanding the role of electrolytes helps us control and manipulate colloidal systems for various applications. Now, let's discuss protective colloid. Protective colloids are substances that stabilize other colloidal systems by preventing coagulation. They form a protective layer around colloidal particles, keeping them dispersed. Gelatin, casein, and gum arabic are common protective colloids. These substances are used in food, pharmaceuticals, and cosmetics to enhance stability and shelf life. Protective colloids are essential for maintaining the quality of many products. Next, let's look at associated colloid. Associated colloids, also known as micelles, are formed by the aggregation of molecules above a certain concentration, called the critical micelle concentration. Soaps and detergents form micelles in water, allowing them to clean and emulsify oils. Associated colloids are important in cleaning, personal care, and pharmaceuticals. Their unique structure enables them to solubilize otherwise insoluble substances. Now, let's discuss lyophilic and lyophobic colloids. Lyophilic colloids are systems where the dispersed phase has a strong affinity for the dispersion medium. These colloids are stable and reversible, meaning they can be reconstituted after precipitation. Examples include starch and gelatin in water. Lyophilic colloids are used in food, pharmaceuticals, and cosmetics due to their stability and ease of preparation. Next, let's look at lyophobic colloids. Lyophobic colloids have little or no affinity between the dispersed phase and the dispersion medium. These colloids are less stable and require special methods for preparation and stabilization. Examples include gold sol and ferric hydroxide sol. Lyophobic colloids are sensitive to electrolytes and can be easily coagulated. Understanding the differences between lyophilic and lyophobic colloids is important for their practical use. Now, let's discuss the importance of colloids in daily life. Colloids are everywhere in our daily lives. From the milk we drink to the clouds in the sky, colloidal systems impact our food, health, and environment. They are used in cleaning products, medicines, cosmetics, and even art. Understanding colloids helps us make informed choices and appreciate the science behind everyday products. Now, let's summarize what we've learned about colloids. We've explored the definition, types, and properties of colloids, including the Tyndall effect, Brownian movement, and coagulation. We've seen how colloids are classified, how they behave, and their importance in various fields. Understanding colloids allows us to innovate in food, medicine, industry, and environmental science. Their unique properties make them essential to modern life. Let's look at some interesting facts about colloids before we wrap up. Did you know that the blue color of the sky is partly due to the scattering of light by colloidal particles in the atmosphere, or that gold sols were used to color stained glass in medieval times? Colloids are also used in nanotechnology and advanced materials. Their study continues to reveal new applications and insights. Now, let's conclude our journey into the world of colloids. Colloids are a unique and versatile class of mixtures with fascinating properties and countless applications. From the food we eat to the medicines we use, colloids play a vital role in our lives. Understanding their types, properties, and behaviors helps us innovate and solve real-world problems. As science advances, colloids will continue to be at the forefront of new discoveries and technologies. Thank you for joining us on this exploration of colloids.